Hey everyone, welcome back to Generative AI. It's wonderful to see you here. I hope you're having a productive day. Today, I want to talk about something exciting that Google has recently introduced, Gemini Diffusion. If you follow advances in generative AI and image synthesis, you've no doubt heard of diffusion models like Stable Diffusion and DALL-E. These tools let anyone generate detailed images from simple text prompts. Gemini Diffusion represents Google's next step in pushing the boundaries of what's possible with AI-based image creation, and it brings a host of new features and improvements designed to make the process faster, more reliable, and more accessible. Imagine you're a content creator who needs unique visuals but lacks the budget for professional designers or expensive stock content. With Gemini Diffusion, you can generate custom images that match your exact vision. This iterative denoising process gives diffusion models their signature ability to produce high-quality, coherent images that capture both global structure and fine details. Google's researchers introduced several improvements. First, they trained Gemini Diffusion on an enormous, diverse dataset. Instead of relying mainly on English language captions and Western aesthetic images, they incorporated content from multiple languages and cultures. By accessing billions of images and associated metadata, the model learned a more global artistic vocabulary. It can generate visuals that reflect a wider range of cultural styles, from traditional art forms to contemporary design trends. Whether you want a Japanese ink painting, an African textile pattern, or a Nordic winter scene, Gemini Diffusion has seen enough examples to produce authentic results. Another innovation lies in the model architecture. Gemini Diffusion combines transformer-based modules with convolutional diffusion blocks. Transformers excel at understanding long-range dependencies, ensuring consistency in lighting, perspective, and overall composition. Convolutional layers efficiently handle local textures and fine-grained details. This hybrid design means the model can generate images that are both globally coherent and rich in intricate patterns, whether you want a photorealistic landscape or a stylized illustration. By fusing these two paradigms, Google's engineers achieved a balance between high-level scene understanding and pixel-level fidelity. Speed matters when you're generating images on demand. Early diffusion models required dozens or even hundreds of denoising steps to produce high-quality outputs, resulting in slow performance. Google's team developed a more efficient sampling algorithm, cutting the required steps to around 20 while retaining image quality. Faster generation means smoother integration into web apps, design tools, and rapid prototyping workflows. Imagine iterating on a design concept. Instead of waiting minutes for each variation, you see results almost instantly, allowing you to refine your prompt and explore new ideas in real time. Let's talk about what makes the user experience seamless. Gemini Diffusion integrates with Google's existing AI platform, so developers and designers can access it through a simple API. If you have a Google Cloud account, you enable the AI image generation service, set up authentication, and send requests specifying your text prompt, desired resolution, and style preferences. An optional guidance scale parameter controls how faithfully the model adheres to your prompt versus exploring creative variations. A higher guidance scale yields images that stick closely to your description, while a lower scale lets the model introduce more unexpected elements. This balance allows you to find the sweet spot between precise control and serendipitous discovery. One of the most useful features is in-painting. Suppose you have an image with a blank or damaged region. You upload that image, draw a mask over the missing part, and ask Gemini Diffusion to fill it in. Whether you're restoring old photos, completing sketches, or adding elements to an existing design, the model understands context and generates content that blends seamlessly with the surrounding pixels. Outpainting takes this further. If you want to expand a scene beyond its original frame, you upload the image and define the area to extend. Gemini Diffusion then imagines what lies outside the current boundaries, creating a coherent extension that feels like an organic continuation of the original. Safety and bias mitigation are critical when working with generative AI. Training on vast internet data carries the risk of absorbing harmful stereotypes, offensive symbols, or explicit content. Google tackles this with a multi-stage filtering pipeline. During data curation, they use automated classifiers and human reviewers to remove images that violate policy, like hate speech, sexual content, or copyrighted material. During training, they employ techniques to reduce overfitting to biased patterns, promoting fairness and diversity. And during inference, additional safeguards prevent the model from generating explicitly disallowed content. If a user tries to request prohibited imagery, the system returns a safe completion or rejects the request outright. Comparing Gemini Diffusion to other models highlights its strengths. In benchmarks, Google's model often outperforms competing systems in photorealism, color accuracy, and consistency across similar prompts. If you ask for a sequence of images illustrating a snowy mountain village at sunset, with slight variations, Gemini Diffusion maintains coherent lighting and mood across all versions. It also excels in handling multilingual prompts. If you write un atardecer en la aldea alpina or un coucher de soleil dans un village alpin, you receive accurate visual interpretations that respect linguistic nuances. This multilingual capability broadens the model's appeal to users around the globe. Every tool has trade-offs. Some artists prefer the stylistic quirks and artifacts that give character to images from other diffusion engines. Those imperfections can feel like an artist's brushstroke or evoke a handcrafted aesthetic. Gemini Diffusion aims for high-fidelity realism and broad versatility, which can sometimes feel more like a digital photograph than a painterly creation. Depending on your artistic goals, you might choose one tool to generate an initial concept and another to add texture or stylized effects. For instance, you could generate a base image with Gemini Diffusion and then run it through a separate stylization model to get that watercolor or oil paint look you love. A key component under the hood is the attention mechanism. Standard transformers require computing attention scores for every pair of tokens or pixels, which scales poorly as image resolution grows. Google's engineers developed optimized attention kernels that approximate full attention with lower complexity. This innovation dramatically reduces memory usage and inference time, enabling high-resolution generation up to 1024x 1024 or higher on standard GPU hardware. You don't need a specialized supercomputer to run Gemini Diffusion. Cloud-based GPUs or even powerful consumer cards can handle most use cases. Consider how you might incorporate Gemini Diffusion in a real project. Suppose you run a small online store selling custom apparel. You want to offer a feature where customers can design their own t-shirt graphics. Instead of licensing thousands of images from stock repositories, you integrate the API so users can type prompts like vintage-style bicycle in a city park, ink illustration, and receive a unique design instantly. The user can tweak style parameters, try different color palettes, or adjust composition. This on-demand approach not only saves licensing fees, but also gives your customers an interactive, fun experience that keeps them engaged. Beyond e-commerce, educators can leverage Gemini Diffusion to create dynamic teaching materials. Teachers often struggle to find illustrative images tailored to specific lessons. With generative AI, they can generate diagrams, historical scenes, or conceptual art that matches their curriculum. Imagine a biology lesson on marine ecosystems. A teacher could request a detailed cross-section of a coral reef ecosystem, showing diverse fish species and colorful corals, and receive a clear visual aid that helps students visualize complex interactions. These bespoke images can make lessons more engaging and accessible, especially when traditional resources are limited or outdated. In research and scientific contexts, visualizations are essential. Researchers writing papers or presenting at conferences need clear, accurate diagrams. While domain experts typically produce these by hand, they can use Gemini Diffusion to draft initial figures or inspiration sketches. For instance, an astrophysicist might ask for a stylized rendering of a binary star system with accretion disk, digital painting to illustrate a talk. Though final figures require domain-specific refinement, the AI-generated drafts save time and spark creative ideas, allowing scientists to focus on analysis rather than graphic design. Developers building mobile apps also find value in on-device or cloud-assisted image generation. Suppose you're creating a travel app that highlights local culture visually. Instead of relying solely on user-uploaded photos, your app could generate concept art for itinerary suggestions. If a user plans a trip to Kyoto, the app might display a serene temple garden with autumn foliage and traditional architecture to set expectations. This dynamic content enriches user engagement without requiring a large database of pre-made images, making the app feel fresh and personalized for each traveler. One natural question is how to access the service. Google provides Gemini Diffusion through a RESTful API on Google Cloud. After enabling the AI image generation API, you authenticate with a service account or OAuth, then send HTTP post requests with JSON payloads specifying your prompt, style attributes, resolution, and other options. The API returns a URL or base64 encoded image data. Code samples in Python, Node.js, and Java show how to integrate with minimal effort. Pricing is usage-based, typically measured in compute units tied to resolution and inference time. Google often provides free trial credits or a limited free tier so you can experiment before committing to production usage. Google also partners with select platforms to embed Gemini Diffusion in existing design tools and creative suites. If you use popular graphic design software, you might soon see Gemini Diffusion as a built-in feature. Click a menu, type a prompt, and watch the canvas populate with generated artwork. This tight integration blurs the lines between AI generation and manual editing. Another consideration is transparency. Suppose you build a social media app that automatically generates profile pictures based on user descriptions. Make sure you indicate in your terms of service that generated images come from an AI, not a real photographer. Provide users with the option to refine or reject results. If you collect data for future model improvements, be explicit about data retention and privacy practices. Responsible AI means thinking beyond just what's fun and novel, anticipating real-world impacts on privacy, trust, and societal norms. Looking toward the future, the promise of Gemini Diffusion extends beyond static images. Google's research hints at integrating audio and video signals, leading to multimodal synthesis. Advances in neural rendering and 3D model generation might let you provide a rough 3D shape or mesh and have the AI produce a fully textured render. While those capabilities aren't yet mainstream, the trajectory is clear. Generative models will soon handle richer, dynamic media, opening doors to immersive experiences, virtual reality environments, and interactive storytelling guided by natural language. For now, the best way to learn is hands-on experimentation. I encourage you to explore the API, test various prompts, and see how small changes affect the outcome. Even simple tweaks, like adding style descriptors, such as in the style of watercolor or digital oil painting, can dramatically transform the final image. Share your favorite results with the community to inspire others, and don't hesitate to participate in forums or GitHub discussions where developers swap tips and showcase techniques. You'll be surprised by how much experimentation helps you understand the model's strengths and quirks. As you dive in, remember that an AI model is not a replacement for human creativity. It's a tool that augments our abilities, helping us iterate faster and explore ideas we might not reach on our own. For artists, consider AI as a collaborator. Feed it concepts, let it surprise you, then reinterpret the results through your unique vision. For businesses, think of generative AI as a way to scale creative production while maintaining authenticity. And for educators or researchers, use it to spark curiosity and facilitate learning. When used thoughtfully, these tools become extensions of our own creative potential rather than mere gimmicks. Thank you for listening and being part of this community. If you found this overview of Google's Gemini Diffusion helpful, please give it a thumbs up, share with your friends, and subscribe for more insights on generative AI, creative workflows, and emerging technologies. Leave your thoughts and questions in the comments below. Did you try a wild prompt that yielded surprising results? Are there use cases you want me to explore in future videos? I love hearing from you and learning how you apply these tools in your unique ways. Until next time, happy generating, and embrace the creative possibilities that AI makes possible. Enjoy exploring new creative horizons with Gemini Diffusion. It's a game changer.